Ah yes, I see you're back for the answer for how to draw the Lewis dot diagram for acetone. If you haven't watched my double and triple bond lesson before this, please make sure you go check that out for some extra help in how to set up double and triple bond Lewis dot diagram problem. Let's start by noticing that there are 3 total carbons in 1 molecule of acetone. Altogether, there are 6 hydrogens, 3, 6. So there are 6 hydrogens, and there is 1 oxygen. We need to draw each atom separately at this point. So we have 1, 2, 3 carbons. We have 6 hydrogens, 1, 2, 3, 4, 5, 6. And we have 1 oxygen, 1 O. We now need to draw the valence for each of these atoms individually. We know that carbon has a valence of 4. If you look at your periodic table, you count over group 1, 2, skip the transition metals, 3, 4. It's in that 4th column, therefore has 4 valence electrons. We're going to put 4 dots around each carbon. I play ring around the atom, so I don't pair up any of the electrons first. I go around and then go back and pair. For hydrogen, we know hydrogen has a valence of 1 by looking at our periodic table because it's in that 1st column. So each hydrogen is going to have 1 electron that it can share with somebody else. Now oxygen's our final atom, and oxygen, if you count over again our little trick that we use on the periodic table, oxygen is number 8 on the periodic table, and if we use our little trick of counting over each column, we can figure out the valence of oxygen. So we've got 1, 2, skip the transition metals, 3, 4, 5, 6. So oxygen's in the 6th column right here. It has 6 valence electrons. Let's show that by drawing 6 dots around oxygen, ring around the atom style. 1, 2, 3, 4, 5, 6. On oxygen, we notice that there are 2 lone pairs that we're going to leave alone. Don't touch them. So these 2 lone pairs are already happy. They already have a mate. Leave them alone. What we need to do now is connect all of the other atoms together in such a way that they are literally all connected. We don't want to connect 2 hydrogens together because that creates an H2 molecule that's separate from the entire molecule. We want all of these atoms to have lines to each other in some way, shape, or form. First, let's get the hydrogens on there. I'm going to connect a hydrogen to a carbon, hydrogen to a carbon, maybe a hydrogen to an oxygen. I don't know. Let's try it. We got to make sure they're all connected somehow. How about this hydrogen there? How about this hydrogen there? How about this hydrogen there? Okay. Now let's see what else we can do. We can do, the carbons have to be connected to each other in some way. Cool. And now this carbon has to be connected to, well, that doesn't work, does it? Because we have over here 2 unpaired lonely electrons. So this configuration doesn't work that we've just tried. Try again. Round 2. Fight. We need to connect all of these together. Let's try connecting carbon, hydrogen, carbon, hydrogen. Maybe carbon, hydrogen, carbon, hydrogen. Maybe carbon, hydrogen, carbon, hydrogen. Okay, let's see if that works. Now, if we connect that one to that one, that one to that one, could we do this? Well, that certainly uses them all up. Let's see what the final product would look like if we do it that way. We would have C, C, C. Let's number these guys. 1, 2, 3. We'd have 1, 2, 3. Connected to 3 and 1 would be oxygen. And then on carbon 1, we would have 2 hydrogens. And on carbon 3, we would have 2 hydrogens. And on carbon 2, we would have 2 hydrogens. Okay. Technically that is correct in terms of being able to pair everything up. Oxygen's got 2 lone pairs still. Everything else has an octet. They're all happy. Great. What we've created here in organic chemistry would be a kind of cyclic structure. Now, this would not be very common. This isn't going to happen. So let's try another configuration of how these all could bond together and still fulfill all the octets. So what I have drawn is not acetone, but it does work out. Well, how do I know that I didn't get it right, Mrs. Duckonta? Hopefully your chemistry teacher would be forgiving, and if you come up with an answer like that, they would still give you the points for it because you've technically connected all of them together. Knowing that that's not acetone comes with experience and practice. Let's try actually making acetone. All right, so the way acetone works is that you've got a double bond between one carbon and the oxygen atom. So I'm going to start off with that. This guy here and this guy here. Let's just do it to the same carbon. Then we've got some hydrogen connections. We've got some hydrogen connections. And let's make sure to connect those carbons together too. Now we have two final hydrogen connections we can make on the carbons, and then that would be our connection altogether. That looks like a mess. We got to clean that up. What we find is that acetone looks like this. So notice here, it's a little bit different than what you've seen before. From this carbon's perspective, it has its octet. From this carbon's perspective, it also has its octet. And finally, from the middle carbon's perspective, it has its octet in two single bonds and a double bond. And we've also left the lone pair on electron completely alone. That is the structure for acetone. I hope that was helpful. Please click that thumbs up button for me and subscribe to my channel if you haven't already. Hope your day is just ducky.
No ducks, no glory.